Lesson 8.1, Introduction to Logarithms, Part 3, Special Logarithms. In this lesson, you're going to be able to evaluate special logarithmic functions. Now, there are two very special logarithms that we need to be familiar with. The first one is the common log. As is the case in algebra, there are certain things that occur so commonly that we don't actually write it down. For instance, when I write the variable x, you assume the coefficient to be 1 and you assume the exponent to be 1. Because it's so common to write it that way, we don't write 1x to the first, we just write x, and we imply that there is x being multiplied by 1 and being raised to the first power. Well, the same is true with logarithms, except it's not 1 that's the common base, it's 10 that's the common base. A logarithm with a base of 10 is referred to as the common log. So instead of writing log base 10 of x, you'll often see it abbreviated as log x. If you don't see a base on a logarithm, you can assume that this is the common logarithm and that the base is 10. The other very special logarithm is going to be the natural logarithm. Recall that we talked about a special number in a previous lesson called the natural base, or Euler's number. The natural log is a logarithm with base e, or base natural number. Instead of writing log base e, you'll see that abbreviated to be ln. Anytime you see ln, that's log base e. ln, the natural log, is log base e. Take a moment, look at your calculator. If you have this one or a calculator similar to this, you may notice in the left side of this calculator I have a log button and I have an ln button. Those are the common log and natural log buttons. The calculator kind of reminds you what ln and log stand for based on the secondary operations on those buttons. If I hit second ln, it's actually e to the x. If I hit second log, it's actually 10 to the x. So common log, natural log. Take a moment using that calculator. Go ahead and evaluate each of these expressions. Pause here, play when you're ready. Alright, this is mostly about just making sure that you know how to use your calculator properly. So when I type these operations into my calculator, notice I don't bother putting the second parenthesis to close the statement because the calculator itself will do that for me. ln of 5 is 1.609, log of 2.5 is 0.397, log of 4 pi is 1.099, e squared 7.389, and 2e raised to the pi ln log of 5 would be 0.649. So I've got those answers there. Alright, now let's practice without the aid of the calculator. So put the calculator away. We are done with it for this lesson. Go ahead and pause here and try these four on your own. Play when you're ready. Alright, let's look at the first one first. Log of 1,000. Well, first off, the key is to recognize there's no base there, therefore the base must be 10. This is actually log base 10 of 1,000. So we use the same technique for evaluating logarithms that we've been using since the last lesson. 10 to what power gives you 1,000? 10 to the x equals 1,000. Beautiful thing about powers of 10, it's really just a matter of counting up the zeros. 1,000 is 10 to the third, so log of 1,000 would be 3. Anytime you're doing common log of a 1 with a bunch of zeros, it's just however many zeros you have, that's your answer. Next we have ln of e. Recall that ln is an abbreviation for log base e, so this is asking e to what power gives you e. Well, to get from e to e using a power, that's just going to be 1. Also, recall that we had a rule that said log base b of b was always going to be 1. Since the base matches the input value, we know the answer is 1. Moral of the story, anytime you have ln of e, you can essentially cancel it out and your placeholder would have to be 1. Taking a look at these. Now notice on question C we have ln and we have e, but that e is trapped within multiple layers of a function, so we can't just cancel the ln and the e and say that the answer is 1. That wouldn't make any sense. We need to rewrite this in an exponential form. Well, first thing I recognize is 1 over anything can be written with a negative exponent, so I'll rewrite 1 over root e as root e to the negative 1. I then recognize that a square root is really a 1/2 exponent. So if I rewrite square root of e as e to the 1/2, and then that's raised to the negative 1, that's going to really say e to the negative 1/2. Now ln is log base e, so this is asking e to what power is e to the negative 1/2? Well, negative 1/2 would be the power that e is raised to get e to the negative 1/2, so negative 1/2. So in this case, recognize ln and e, they have the same base, so ln is log base e and e to the negative 1/2 is base e. So it's just a matter of canceling that out and you're left with negative 1/2. Anytime you have log base b of b to the x, log base b cancels with the b and you're just going to be left with x. We'll talk more about that particular rule in a future lesson. Finally, ln of log of 10. Follow the order of operations. So we'll start by evaluating the inside first, inside the parentheses first. Log of 10, that's a common log. Just count the zeros. So log base 10 of 10 is going to be 1. And then our next layer would be ln of 1, and ln is a logarithm, and as we said before, any logarithm evaluated at 1 will always be 0.